안녕하세요. My name is Adam Koch. I work on the developer relations team based in Australia. And I'm very excited to be here today to talk to you in Seoul about best practices to slim down your app size. So today I wanted to cover three main topics. One is how to think about your APK size and why it matters for the success of your app. Then we'll walk through a series of best practices for reducing your app size. And then I wanted to touch on a series of new features and tools that we've launched recently to help you manage your application size. So let's get started. So at Google, we really think that APK size matters. We think it's important for Google Play, but also for developers and, of course, for users. We think it does improve the user experience. And to show you that, I wanted to demonstrate with some data. So there are really two kinds of APK size that I wanted to get you thinking about. First of all, there's download size. So that's the size that gets sent over the wire to the user's device. Here you see Google Allo being downloaded from Google Play, and the user can track how much of it has been downloaded and the total download size. The download size is typically highly compressed as it gets delivered from Play to make sure that the user saves as much as they can on their data plan. After that APK is downloaded to the user's device, it gets unpacked onto the user's device. After all, an APK is really just a zip file. After that, certain parts of that APK are compiled and optimized. In particular, the classes.dex file, which is the compiled bytecode, will have some additional compilation optimization steps applied before the user can run the application. Now, all this final size adds up to the total size on disk that ends up being stored on the user's device. So that's the second size I wanted to get you thinking about, the total size on disk. And of course, that installed size will always be much larger than the download size, which has been highly compressed. So let's first talk about download size and why that matters. Why should you care? Well, as users attempt to download an app, they may in fact click the cancel button when it's taking too long or struggling to download on the network. Or they may get to your Google Play listing and see how large it is and never actually bother to hit the install button at all. So that's not good for your application distribution. Here's some data directly from Google Play to back it up. As download size approaches 100 megabytes, we see cancellation rates reach almost 20%. And you can see as download size decreases, so too does cancellation rates. Now let's talk about why installed size matters. Here you'll see a very similar graph to the download size. Well, what's going on here? Well, as a user goes and uses their device, they'll take photos, videos, they'll install apps and games. And eventually, that device will get full of storage. Then they'll go to their system settings and try and uninstall applications to free up some space. And they'll normally uninstall apps that they haven't been using and that are using a lot of space on the disk. In addition, they may have automated apps that suggest apps for them to uninstall. And Google Play now even suggests apps to uninstall when a user's device is full on storage. Now here's some more data to back it up. You can see that apps which use up more than 100 megabytes on the disk are 8 times more likely to get uninstalled versus an app that's 15 megabytes or under. So there's a really big difference here. So hopefully that's some helpful data to help you understand why both download size and install size on disk is important. One other reason I wanted to call out is that we have a bunch of new products that have launched or are launching soon that also rely on application size being particularly optimized. One of those products, which I'm really excited about, is something called Android Instant Apps. And there's a talk covering that product directly after this one, so stay tuned. Okay, so you want to reduce app size. What do you do? Well, today I wanted to talk about a demo application that we have on GitHub called Topeka App. This is a pretty basic quiz application that lets the user log in and answer some questions and get some points. I wanted to go through and analyze it and see how we could optimize the size. So on the left here, you see a breakdown of what's inside that APK. You see that the resources directory, which typically holds a lot of your graphics and drawables, takes up 67% of that APK. And then the DEX bytecode takes up the majority of the rest of that APK, at around 31%. There are also some additional resources, things like the ARSC file, which hold smaller resources that take up space, but it's not a significant amount. So we're really going to focus on the resources and DEX optimizations. Now, one other bucket that's missing from this today is native code, shared object files or .so files, which a lot of applications also have. I'll cover some tips for optimizing that a little bit later in this talk. Okay, so let me quickly show you one of my favorite tools for getting a sense for what's inside an APK. Can we switch to the demo? Okay, so here I'm in Android Studio, and it's a little bit small. I'll zoom in a second. But to access a built-in tool called APK Analyzer, you go to the Build menu at the top, and you select Analyze APK. And I'm going to choose a version of Topeka that's been built directly from GitHub. Okay, so hopefully most of you have seen this tool, but if not, let me explain a little bit. At the top, we see the raw file size. So this is the size on the disk of my laptop. And then right next to that, we see the total download size. This is the compressed download size that Google Play will actually deliver to the user's device over the network. So that's pretty handy to see. On the right side, you can actually click a button called Compare with Previous APK and see a side-by-side difference between two different APK files. And then below that, in this top pane, you see the different categories inside that APK sorted by download size. At the very top, as we noted before, is the resources directory. Now you can see it's using 2.9 megabytes with a download size of 2.7 megabytes. We can even drill into this directory to see what's using up the space, again sorted by size descending. Here we see that drawable-xxx HTTPI is using the most space, which makes sense because that's got your highest resolution drawables. We can even drill into that and see one of the drawables that's using up the most space. It's this nice graphic for our quiz. Now below that, we see the other density buckets, XXHTTPI, XHTTPI, HTTPI, and so on. And that makes sense because we have to keep the drawables in different resolutions for different devices. However, there's a lot of duplication of resources here, and so I'll discuss some ways we can handle that a little bit later. Now below that, we have our classes.dex file, so this is our dex bytecode. Clicking on this file populates this bottom pane here, and lets us see which packages and classes in our dex file are using the most methods and the most space. Here we can see that the Android package, and if I drill into that, the support library is actually using up the majority of the space in our code. These columns next to it give us some additional information. We see the defined methods and also the referenced methods. And on the very right, we see the actual size used by that package and the classes that it contains. That size column is something we added very recently and is only available in Android Studio 3.0 preview. So I encourage you to get that version of Android Studio and try it out. Now below this, we can actually go and look at our other files as well. We can look at the resources, the ARSC file, metainf, and also Android manifest. But as I mentioned before, these don't use up that much space, so we're not going to focus on optimizing those. Okay, let's go back to the presentation. All right, so what are we going to do to optimize the size? The first step is to enable something called ProGuard. Hopefully, most of you have heard of ProGuard before. ProGuard is a whole program Java optimizer, which does a few different things. It optimizes your code, such as inlining methods. It obfuscates names of types, methods, and fields where appropriate, such as reducing a long method name down into just a single letter like A, B, or C. And most importantly, for size, it does dead code elimination. Now, to enable ProGuard, you can go to your build.gradle file and just set minify enabled to true. So what is dead code elimination? Well, if you think of your program as a graph of classes, methods, and fields as nodes, and the calls between them as edges, then your application could be represented somewhat like this, where my activity calls my class 1 and my class 2, my class 3 calls my class 4. Now, Android has very well-known entry points, things like activities, services, broadcast receivers. And so what ProGuard can do is go to those entry points and trace through your code and work out which classes it's actually using and which classes it's not. In this case, we can see an entry point at my activity, which calls my class 1 and my class 2. However, there is no entry point that touches my class 3 and my class 4. And this means that ProGuard can actually go and remove those classes from your application when it compiles it. Let's have a look what happens when we apply this to our Topeka app. We can see that the classes.dex file is immediately reduced down to 33% of what it was before. That's a really significant savings. You're probably thinking, well, where is all that code savings coming from? Like, how did I have so much code that wasn't being used? Well, do you remember we looked at the APK before, and we found that the support library was using up almost half of our classes.dex file. Now, the support library offers a lot of useful functionality, but a lot of apps don't need to use all of the functionality in the support library. And so what's happened here is ProGuard was able to remove all of the features from the support library and other libraries that our code never actually used. The next step is to enable something called resource shrinking. You can enable this in your build.gradle after you've enabled ProGuard by setting shrink resources to true. What does resource shrinking do? Well, it's pretty much the same thing as ProGuard's code removal, except it does it for resources. So here you can see, again, your classes mapped out and which resources they're referencing. Now, if there's resources that are not being referenced by your classes, then those too can be removed from the compiled APK. This is what happens when we enable resource shrinking on our Topeka APK. You can see that the resources shrink down to just 25% of what they were before, which is significant savings. What's going on here? Well, it's the same thing. Things like Google Play Services, Support Library, and other libraries all have resources that cover a very broad range of functionality. However, our Topeka app only uses a few of those features and only needs some of those resources. So those have now been removed from our compiled APK. All right, we can continue though. Let's do more. So we can do something called multiple APKs. Now, if you recall, when we looked at the resources directory in our APK, we had a number of different density directories. We had XXX-HTTPI, XXHTTPI, so on and so forth. Now, normally when you build your application, you get one single APK that includes all those resources. When we enable this flag in our build.gradle, we'll actually generate a single APK for each density bucket within our project. So we might output 5 different APKs, with each one built with the resources for exactly one density bucket. Now, Google Play has a feature to actually upload all of these APKs into Google Play and have them distributed out just to the right devices. However, what we've found is that it's quite difficult for developers to actually get those uploaded and distributed in Google Play. And so later on this talk, I'll tell you about a way where we can actually do all of this automatically for you, so you don't actually have to build the APKs yourself. All right, so if we apply this and build an XXHTTPI version of our APK, we can decrease our APK size once more. Now, speaking of drawables, one additional optimization is using something called vector drawables. Vector drawables were actually introduced in very recent versions of the Android platform. However, we subsequently released a support library implementation of vector drawables, which you can enable in your build.gradle using vector drawables.useSupportLibrary true. So what are vectors? Well, they're a different way to represent images. You can basically define your image in terms of lines, shapes, and colors, rather than the individual pixels in that image. Here we see an icon that's represented as a vector drawable, taking up only 5 kilobytes. And this allows an individual device to actually rasterize that image at exactly the right density for any resolution device. Compare this to the PNG equivalent, where you'd have to include 5 different versions of that same graphic, adding up to over 100 kilobytes of data use. Now, as I mentioned, vector drawables work in the support library all the way back to API level 14. However, there are some features that are only enabled in newer versions of the Android platform, such as gradient support, which works in Android API level 24 and above. Okay, so let's apply this to our Topeka app once more. We see that we can reduce our APK size down again. This time, almost to half a megabyte, down from a total of 4 megabytes before. Okay, so let's shift gears a little bit and talk about some new things that we're working on. I showed you APK Analyzer before, and we really want you to go out and use that tool to try and analyze your APKs. However, as of Android Studio 3.0 and going forward, we plan to invest more into this tool. In fact, Android Studio 3.0 Preview already has a lot of these features implemented that you can use. Things like UI improvements, multi-deck support, showing the bytecode of a class, finding method usages, and additional features for ProGuard as well, which I'm going to demonstrate for you now. Okay, so we're back in Android Studio. I'm going to go to Build, then Analyze APK. I'm going to choose a version of Topeka that was built with ProGuard enabled. Okay, this time you can see the classes.dex file is a lot smaller because ProGuard has removed a lot of that code. Now, if I drill into this, what you'll see inside the COM package is that the naming is just A.A.A.A. And that's because ProGuard has gone and obfuscated the class names. And that's not going to help me understand what's inside my APK. And so in the new version of APK Analyzer, you can actually go here to this button and click Load ProGuard Mappings. And then you load the mappings files that were generated when you built your APK. Now if we drill down here, you'll see that all of the package names are now visible again, so I can see exactly where the space is being used. Furthermore, you can click this button here called Show Remove Nodes. And what this does is it lets you see which classes and packages were removed by ProGuard. Here we can see that the class fragment, median compat, transition, and so on have been removed by ProGuard because it deemed that they weren't being used. However, sometimes ProGuard can make mistakes, and sometimes that class is actually required by your application. Straight from APK Analyzer, you can actually right-click this and click Generate ProGuard Rule. Now, it's a little bit zoomed in, but what you can do is you can just highlight this and copy and paste it into your ProGuard configuration, rebuild your application, and that class will now be included in your compiled binary. Okay, let's switch back to the presentation. So another new tool that I think was mentioned in an earlier session today, something called downloadable fonts. So in the past, if you wanted to include a custom font, you actually had to include the binary directly in your APK. And that would sit both in the download and then also on the disk afterwards. Even if 5 apps used exactly the same font, they would all have to include that binary inside their APK. Now with downloadable fonts, there's actually going to be a central repository on the system that all apps can reference. One copy of the font for everyone, which saves APK size, memory, disk space, and network. Now, we didn't want this to just be available on newer versions of Android, so it's in the support library via Google Play services as well. Initially, we're making the entire Google Fonts catalog available to all applications, but we look to add more fonts in the future. Now, the last feature I wanted to talk to you about is something called Google Play App Signing. Now, this is a pretty broad feature, and I don't have a lot of time to cover it today, but let me give you a quick overview. So in the past, when you built your production application, you actually had to sign that APK with a certificate. Then you upload that to Google Play, and it tells Google, as well as users' devices, that this APK is coming from the developer that it says it's coming from. That's great, but what happens if you ever lose your certificate or your certificate gets compromised? Well, actually, in that case, there's nothing Google Play can do to actually fix the situation. You're going to have to go and create a brand new application, a brand new certificate, and migrate all your users over, which is not great. With Google Play App Signing, we take your signing certificate and then we store it securely in the cloud. And then we sign the APK when it gets delivered down to the user. This is really great for just managing a certificate, but it has some extra side benefits as well. Now, remember before I was talking to you about different density buckets and how we don't want to deliver all of those down to a user's device when they only need one of them. Well, the same is true of native code, .so files. If you have native code, you're going to have to build for ARM, for MIPS, for x86. And unfortunately, you're going to have to deliver all of those binaries down to every user's device, even if they only have one CPU architecture that they need. In this case, we see a user with an ARM v7 device and HDPI only needing the two blocks in blue, but they're actually going to receive all of the blocks in, I guess it's turquoise. So, with Google Play App Signing, what we can do is apply additional app optimizations after you've uploaded your APK. Why can we do this? Well, because we now have your signing key, we can actually go and re-sign the APK after we've made any modifications so that it's signed with the right certificate. So what does this mean? Well, we can enable a feature in the future that does something called auto multiple APK. This means you can just upload a single APK to Google Play, which has all those assets in it. And then we can go and generate all the different combinations of APKs and deliver just the right one down to the user's device that matches their device specs. Now, this is not enabled for everyone yet. It's something that the team is working on and looking to launch in the future. However, Google Play App Signing is available right now and something you can enroll in if you would like. Now, we expect the initial savings for developers to be around 15%. However, we tested this with a few early access partners, and we found even greater savings. Deliveroo, a food ordering app, saw 33% smaller APK sizes. And 7, a workout app, saw almost half the size of their APKs after enabling this. Now, these app optimizations are coming in the future, but for now, you can definitely go and look into app signing and see if you want to sign up for that. However, I did want to call out that app signing is a one-way road. Once you enroll in it, you can't actually unenroll again. So make sure you understand the implications before you do enroll. Okay, so what's next? I highly encourage you to go and check out Android Studio 3.0 Canary, which has a lot of the new features of APK Analyzer I was talking about, as well as a whole lot more outside of just optimizing your APK size. In addition, I really recommend going to look at Google Play App Signing as a way to move your certificate into the cloud and open yourself to these additional advantages in the future. After this talk, I'm going to be out in the Ask the Speaker zone if you want to come and talk to me about any of these features and have any questions for me. Thank you very much. Kamsahamnida.